First off, welcome to the eBeam suite at the Nanotech User Facility at the University of Washington. My name is Scott Braswell, and I'm responsible for this instrument that you see here. This is a scanning electron microscope, an FEI. The model is a Sirion field emission scanning electron microscope. So the basic science behind scanning electron microscopy is pretty simple. It's been around for more than 50 years. It's a way of beating the diffraction limit of light. So any item smaller than half the wavelength of light is too small to see with a light microscope. Electrons have a much shorter wavelength, so we're able to image structures that are a lot smaller than the diffraction limit of light in order to see what's going on at that scale, the nanoscale. The main parts of the microscope that you see here are the column. It's a cylindrical piece. The chamber is the square at the bottom. The table that the system is mounted on, and to your left here is the user console where you do all the microscope manipulations. So at the top of the column, in this section right here, is an electron gun. As I mentioned, this is a field emission scanning electron microscope. So the electron gun is essentially a tungsten filament, a very sharp filament. We use a strong electronic field to draw a current off of that filament, and that creates the beam, the probe beam that you use to impinge on the sample and image the sample. Below the electron gun there are condenser lenses, scanning coils for moving the beam, stigmators for adjusting the roundness of the beam, and ultimately there's a probe lens at the bottom, down at about this level. When the probe, the electron beam, exits from the probe lenses, it then enters the chamber, which is the square section here, and it impacts the sample, where the sample absorbs the energy of those electrons and then re-emits new signals that we use to image the sample.